Hi, I'm Leanpub from Leanpub, and in this episode of the Front Matter podcast, I'll be interviewing Edward Abramowich. Based in Singapore, Edward is an experienced lean enterprise agile coach, continuous improvement expert who has worked for companies like Shell, Petroleum Development Oman, Honeywell, Roche, Kuwait Oil Company, IBM, and others. You can follow him on his website at straitsconsulting.com, and that's Straits as in the Straits of Oman or something like that, and check out his LinkedIn at Lean Coaching. Edward is the author of the Leanpub book, Agile Hardware in Action, a practical guide to building products for the fast-paced world. In the book, Edward shares years of best practices from energy majors and engineering, procurement, and construction companies on how to use Agile hardware methods to deliver cost reductions, schedule and productivity improvement, and deliver better project outcomes. In this interview, we're going to talk about Edward's background and career, his book, and we're going to talk a little bit at the end about his experience writing. So thank you very much, Edward, for being on this episode of the Front Matter podcast.
Oh, Len, it's a real privilege. Thank you very much. And I'm a huge fan of you and your work, and thanks for the opportunity.
Oh, thanks so much for using Leanpub as a platform. The first thing I always like to ask people when the guest is a Leanpub author is to ask them about their origin story. So I was wondering if you could talk a little bit about what we were just talking about before I hit record, about where you grew up and how you made your way into living in, over a dozen countries.
Sure. Well, so I was born in Canada, and I left when I was quite young. Now I've lived in 12 countries. Been traveling across the world for many years. My family were academics, so they taught in various universities. For me, I tried to follow my father's footsteps of becoming a pure mathematician. So I studied pure mathematics in university, but somehow I wasn't as good at pure mathematics as he was. So one day, my wife and I, who we met in university, decided, look, we need to try something different. So we sold everything we had. We got some backpacks and we moved to Japan. We moved to Tokyo, and I was in Australia at that time, actually. So moving to Tokyo was a huge cultural shift. I mean, it's unbelievable how many people would see going to a train station. I think like half the population of Canada goes to the train station every day. But then what happened was I with my mathematics statistics background, I started to I needed to find work, and I started to work in Japanese manufacturing lines, helping with using data and analytics to try and improve the quality. So very early on, I started getting involved in the continuous improvement, the quality and lean type environments in Japan. But to be very honest, the real reason I wanted to go to Japan was actually to study Aikido, because I'd studied Aikido, the martial arts, for many years, and so I went there and also trained Aikido. And then unfortunately I got. Yeah, go ahead.
Yeah, no, that's really amazing. There's a couple of things I would want to talk about there. I'd actually wanting to talk about. I've sort of have done some martial arts in my life by coincidence, and I've got a sort of collection of martial arts books, and a bunch of them are a series from Japan, from I think people from elsewhere who moved there in order to study it. These aren't Aikido books. I've got some Aikido books too, but yeah, going to the place is something that serious martial artists do.
and not being able to speak the language and trying to, it was quite an enriching experience. Let's say that.
Yeah, I can imagine. And yeah, one thing that also reminded me of too, for anyone who's curious about how like some mathematician can end up working on a factory floor or on a factory line. I had a friend once who was doing a doctorate in maths. I think it was like fluid dynamics or something like that. And one day I saw him with a backpack, like, leaving the dorm, and I'm like, Gordon, where are you going? And he's like, I'm not going to do a Scottish accent. Oh, I'm going to the zoo in Edinburgh to help them hatch some penguins. And I always think that was the moment when it finally clicked for me, like kind of what mathematicians do.
Yeah, well, it was. I was very comfortable at the production process. You're manufacturing power supplies or television, and yet they'd have these defects, and so trying to use the data to understand what was going on was at that time the kind of core of continuous improvement, which actually Japan had been leading after the Second World War, through some specialists like Edward Deming, using statistical methods. So it was very comfortable. Then I got exposed to the kind of the Japanese approach to this, which was lean manufacturing. And lean and continuous improvement is one of those things that it's constantly changing. You think you know it, and then all of a sudden it changes. So you really have to start to get used to a learner's mindset and saying that I'm going to really try and learn more and more, because there's no end to this. So I progressed from Japan and then moved out of Japan. I helped a Japanese company actually set up supply chains in China. So I moved to Hong Kong and was doing supplier development in China. So we would find a supplier for a particular component, and then how would we make sure that their quality is acceptable? So we'd have to go in and develop the suppliers and help them and get their processes up to a stage where the quality was fine. Then after Hong Kong, I ended up actually repairing aircraft engines. I started working for an aerospace company in the region here in Southeast Asia, and so their problem is when when an airplane needs a part to be repaired. In this case, it's a jet engine. The time between when that engine needs repairing and when it's back in service is money. It makes a big difference for the airlines. So we started using lean techniques to take that time. I think it was like 65 days, and move it down to like 12 days. And that's using a set of lean techniques in aerospace. So then what I began to realize was that these methodologies, lean, actually apply to any industry. So I went from aerospace, then I went to high tech, then pharma, and right now I'm building very large energy projects, capital, $1 billion projects, helping them optimize the engineering and design. So I've changed many different industries, but the skill set has kind of remained the same. I don't know if that makes sense.
It does, and actually, that's a great opportunity for us to, in a moment, drill into what you mean by lean, because it's really interesting. I think a lot of our listeners probably they first came to the concept of lean maybe through the lean startup kind of idea, and maybe through kind of agile kind of software development practices and things like that. But the origins are in making hard things that you can bang a hammer on to test and stuff like that. And I just wanted to give people some context for the kind of work that you're doing. So as I was researching for this interview, I was looking at your LinkedIn profile, and I believe you're working on the Shell, or a project related to the Shell Prelude floating liquefied natural gas.
Not quite Prelude. Prelude's been built. I've helped these companies with several major projects. So we're actually building an oil platform right now, an oil asset, up for oil and gas asset, and so it's pretty much the same for any energy major. So what happens is they come up with a concept to say, look, here's an opportunity to provide more energy. So we might be looking for natural gas, or it could be sustainable. So these assets cost billions of dollars. And so what will usually happen is they'll go through several stages of engineering. So, for example, the first 2 years will be what's called FEED, front-end engineering development. And so they then take that concept and say, well, let's put a bit more, thought around what this would look like. And they come up then with after 2 years of engineering work, and there could be hundreds of engineers involved in doing this, then get to the point to say, okay, let's now go to more detail. And then they go through a detailed engineering phase. So that's really starting to build a very, very detailed engineering model for whatever asset that might be. There's another 2 years and hundreds of people involved. Then you get to the point where you say, okay, so we know what we're going to build. We have the engineering model, and we're going to now, when we start purchasing the parts, then we start construction. So there's another 2 years. So the challenge for these energy majors is that that 6 years of work is way too long, and it's the way that they work is for the agile folks out there is very, very sequential, siloed, waterfall world. it's a stronghold of waterfall thinking, and projects are. I was talking to one of the engineering majors, and they said, yes, projects are always late, always. They're always the same. They're always late, and when you start to ask, well, why is that? And they said, well, we just stuff happens. We can't expect everything. So agility starts to offer these large projects a very different way of getting faster. And understand with an asset, with these assets. So let's say that I plan to have the asset running at a particular date. Every day afterwards, you're losing millions and millions of dollars of revenue. So the money is phenomenal. So this long cycle is something for energy majors. So we're talking, it could be many things. It could be like floating processing units. It could be a massive shipbuilding, building refineries, building chemical plants. It all follows a similar process. Speed is king. And these organizations and models which serve them well for many, many years, that sort of hierarchical siloed approach, just aren't fast enough anymore. So everyone's trying to figure out how do we get faster. So that's where agility is, and it is really coming to the forefront. And just to your point about the agile and lean, I'm a huge fan of lean startup, but it's been really interesting watching how this has worked because, well, of course, as we know, Scrum came from Toyota and Nissan, the way they develop products, but it found a life in technology and software and technology. So it came up through that startup world. And lean came up through manufacturing, but they're meeting now. And now the challenge for manufacturing companies. So let's say, and I was speaking to actually Jeff Sutherland last night about this, that imagine that you are a software company and you are releasing updates continuously every few hours, like an Amazon or a Microsoft can do. Well, to stay competitive, hardware companies need to do the same now. If you're manufacturing cars and you're not updating and changing that design every few hours, you're going to lose. And there's only a couple companies on the planet that can do that. And most of them seem to be owned by Elon Musk, Tesla, SpaceX. So what we're seeing in the hardware world is agile and lean concepts coming together and manufacturing getting crazy fast. And not just manufacturing, but introducing new features and new products getting fast. But it's the huge challenge for manufacturing companies because it's physical stuff. In a way, software is a bit more valuable, so it's easier. But when you're building stuff, it is a bit harder.
Yeah, I've got a few, one or two threads I'd like to pull on there. But just before we do it, I really have to try and be a good podcast host and say, can you take a moment to talk about what lean is in manufacturing for someone who's like maybe completely unfamiliar with manufacturing or lean or anything like that?
Okay. So just a quick, talking about lean and where that came from. If you don't mind, a little bit of historical context. So after the Second World War, Japan was decimated, and they started to try and create their own industries and things like manufacturing cars. But the demand was very, very small, and so people like Toyota looked to the U.S. and said, wow, we wish we could build factories like Ford or General Motors where we could have, these big production lines and, manufacture huge number of the cars, but we can't. The demand's not there. We have, we might sell, a certain number of models of this truck and then a certain number of this car, but we can't really create these huge production lines. So they had to be very innovative. And they had to say, how do we start to manufacture a wide variety, low volume, a mix of cars for the market? So from that point, what had happened is Toyota, and there's some very famous names like Teiichi Ono, you started to rethink the entire manufacturing process. So what they did is they started to experiment with how production lines should be set up, and out of that was developed what's called the Toyota Production System and Lean. So it was evolutionary. They were learning as they went. So at one point, Toyota was almost bankrupt. I think this was in the 50s. They were really close to bankruptcy. And at that time, Taiichi Ono, who was the vice president of operations in Toyota, basically said, "Look, we don't have any cash. We don't have any cash. What are we going to do?" And he was walking along the factory line, and he noticed that there's all this inventory and all these physical parts waiting to be worked on. He said, "That's where my cash is. It's still stuck in an inventory, work in process. So how can I eliminate that?" So out of that, they identified inventory, work in progress as waste, and started to structure their manufacturing process in a way to eliminate that. So Lean came out of the Toyota production system, and there's dozens of books behind me written on the subject of how do we. Lean is essentially saying that how do we, from the point that the customer buys our product to the point that we receive the cash for that product, how do we shorten that time?
Right.
That's all it is. Then Agile comes along and changes the game completely. We can talk about it.
Yeah, sure. I mean, well, why not? Let's go. That was, by the way, what a great history. I love the way you put it in the context of the post-World War kind of World War II kind of scarcity and, damage that had been done to Japanese infrastructure and the country as a whole, and how this sort of and then this sort of constraint of bankruptcy and things like that, drove Toyota to kind of innovate there. But yeah, if you could talk then for maybe do something similar for a couple of minutes about Agile so that people have that piece of the puzzle.
Yeah. So what's been happening is, things are evolving very, very rapidly. And if we look now at the way that, say, Toyota works, so Toyota will design a car, a Toyota Camry, a Prius, or whatever it might be. They'll design it, and then they will put it into the manufacturing process, and they will optimize that process. So you will get a very high quality car. So they're constantly looking for ways to improve that car, how it's manufactured. But then comes along Agile, which then changes the game. So I mentioned that Lean is about how do you get from the point where the customer buys the product to when you receive the cash, how do you shorten that time? Then what Agile does is it starts to say, well, not just from the point when the customer buys the product, but from the point that we have a new idea for a feature. So let's say that my customers in China really like to have a different radio or a different system in the car. How do we take from the time we know about that opportunity to when we actually deliver that to get the cash? We make the product, we do research and design, we test it, we get roadworthiness for it, we produce it, and we get it to the customer. So what Agile's done is actually taken the research and development, the engineering aspect for it, and put it into the production line. And the crazy thing is that for a Toyota to do that, to change a particular design for a car, would take 2 years, 3 years. In a minimum product refresh, they would take 2 years. Agile organizations like Tesla do it in 3 hours. So in 3 hours, so let's say that they identify, maybe we could make this car go further on the same charge. We could reduce the energy consumption by changing our wiring, for example. They then will re-engineer it on the fly, introduce it into the production line, get roadworthiness for that car, and get it to the customer in hours. So when you look at that, if you've got a company which is introducing new features at radical speeds, it's almost impossible to compete with, because a fixed model over years versus radical improvements quickly, it's a completely different operating model. And that's what the world's trying to catch up with right now.
Yeah, it's really interesting. You got a book. I mean, your book is, Agile Hardware in Action. And if one wants to understand what the in action part is, it's like if you can get down from like years to hours, that's some heavy action there. One of the lines in your book is the pace of innovation is the only competitive advantage in that kind of world. And it's sort of very, we can pick that apart in a second. But one thing I just wanted to say is like when you were talking about the big projects and stuff like that, sometimes I think it's difficult even for people who work in them to sort of grasp the scale of the problems that can happen in those huge projects. Like, for example, in my former days, I was an investment banker. I worked for Macquarie out of London, and I worked on a big global LNG proposal once. And just like the project financing side of things is based on and what that means is borrowing money, basically, and committing capital to sort of some build out kind of timeline and things like that. And sometimes you might even need to refinance the loans you get from the banks before the project is completed. And we would, in our models, we would have to build in sensitivities around timing and things like that. And it can become very, very tricky. And then just to sort of to go from that to this is sort of high finance to I had a friend who worked for a company called, I think it was called Single Buoy. And he was an engineer from France. And I asked him, so what do you do? And he goes, in a year and a half, they're going to need this part at the plant in Nigeria. And I have to make sure it gets there when they need it. And so like the scale and difficulty and like the dimensions involved in carrying out these huge projects are just like vast. And so the challenge of getting it down to hours involves all those, pardon the metaphor, moving parts, that all have to be in sync. And the idea of it's specifically from the project finance perspective, if you can reduce production times. I mean, now we're talking about an LNG platform or like I was working on, but down like a car feature or something like that, cutting down that time and making things more reliable it just has this incredible knock-on value in terms of what you can finance and what you can do.
Yes, absolutely. I mean, these are country government level investments. They're huge and they make or break countries. And these huge assets, that like the largest LNG, floating LNG cost $20 billion, took 20 years to engineer, and it is huge, far taller than Empire State Building. If you laid it vertically, it's huge. And actually, I'm looking at it from a different angle though, and that is that because we're agile in action, so we're actually looking at how people do the work. And what you start to see is in that purchase order example, make sure that part gets there. That process of how do they identify what part it is, how the engineering, etc., that the purchase order of it can take 6 months more. But if you really scrutinize, what are all the steps? So the engineer might come up with a concept, and they do one design, then they have to send that design to another engineering team to verify it. That can easily take 6 months. But when you put the lean lens on, then you start to say, well, actually, why can't you do that in 2 weeks? If you eliminated all that waiting, all that waste, etc., that's happening there, you can do it really, really quickly. And that's where then Agile might say, well, actually that part, what if this is literally happening to us right now? So at the moment, we're issuing purchase orders for one of these massive assets, $20 to $30 million for a generator. And the entire supply chain is completely full. So if I want to go and buy a generator, I'm going to have to wait 2 or 3 years. And if that generator is, if the supplier makes it black and I want it blue, no way. They're not even going to talk to us, right? So suppliers are full. They're really picky. And I spent years getting to the point of reissuing that purchase order. So what Agiles can do then is say, well, you can't supply that generator now? We change the design. Oh. Why not? So you were available. I'm not available. This is not available. So let's change the design on the fly. Why can't we do that? Well, actually, we can. if you were crazy fast, you could redesign on the fly. And so Agile Hardware in action is trying to explore how we do that, how we become crazy fast. It's a big challenge because they're big projects and they're very established companies.
Yeah,
your experiences.
Yeah, no, sorry, that really set me off on a new train of thinking that I hadn't, come across myself reading your book. But that's really fascinating. Just to give an example of the detail that the book goes into. One thing that I learned from it was about the Stacy complexity model. And so just to give people a little bit of a flavor of the things that if you're totally new to this, or even if you're an expert, there might be some things for you to learn. Can you talk a little bit about what the Stacy complexity model is?
Yeah. So, I mean, there's a lot of theory and a lot of concepts in Agile, which can become quite academic. Like again, last night I was speaking with Jeff Sutherland, and he's in the world of high physics now. It's Agile is like fundamental laws like gravity, and if you can't do it, you're gonna you don't win against gravity. So things like Stacy complexity model, I'm trying to take it to a point where it's actionable. That I'm less interested in the academic of it, but actually, what does this mean for a large capital project? And essentially, what it's saying is that if I'm going to build something which is pretty simple, I know what's involved. I don't actually need Agile, right? I mean, I can use good old fashioned waterfall. Just do it. It's pretty simple. Do I really need to go through all that effort of changing the entire business model for these very simple things, these things which in the Stacy model are considered, well known and we know what to do? No, you don't. We can follow the old. But then, as complexity, as these systems get more and more complex, the issue is that you cannot predict what's going to happen. So if I take what works in a very simple world, and let's say I create a very detailed Gantt chart, a very, very long-term plan. So there's this asset which is going to take me 6 years to build. I try and create a project schedule around it. It's going to fail, and it always does. So that means the act of planning actually doesn't work. You really can't predict. So in systems which are very complex, are basically you can't predict. So Stacy model is saying if you're in a system which is really complex, so they have just do it. They have things which are just do it, complex and complexity. Different levels of really unpredictability. Agile fits in a space which really you can't predict what's going to happen. All you can do is create something and get feedback fast. And the faster you get feedback, the more you can iterate towards it. But the problem is that these large engineering projects are in the world that they think they can plan everything. Even though, as I mentioned, speaking to a large engineering house, that they'll admit that everything's always wrong. They never work, but they do it anyway. And so that complexity model is saying just recognize where you're playing, and if you're in this simple space, well, just do it. But if you're in a space which you really can't predict, then you better adjust the way you're working. I don't know if that makes sense.
Yeah, no, that totally makes sense. I'm just looking. If I look a little bit distracted, it's just because I was bringing up the really awesome infographic from your book about the Stacy complexity model, and the thing, it took me a moment to wrap my head around it. But the thing I love about it is on the one axis is the sort of approach to how you're going to do things. And there's increasing uncertainty along that axis. And then along the sort of y-axis, there's requirements. And the sort of version of uncertainty, like approach is like, what am I going to do over time? But the requirements increases in vagueness as things get more complex and difficult. So that I love that distinction between uncertainty and vagueness, and that these are two things that you're dealing with on different kind of dimensions of the same problem space.
It's interesting. Jeff Sutherland was talking about there's a very famous mathematician called Wolfram, and Wolfram actually he was a genius who, like, in his spare time created a software called Mathematica, which is kind of the the most sought after theoretical mathematics, the best mathematical modeling software. And they're actually modeling the universe now. And this incredible system is coming up with things that we're learning new things about it, about how the universe works. And in that sort of philosophical part of it is essentially you cannot predict things. And so the energy and effort going to trying to predict something which is in this complex world it doesn't help, because you're always going to be wrong. So the issue becomes, how fast can we adapt? So I'm going to try something, get feedback, and adapt. And just this as a side note, this is the kind of a philosophical dilemma for the lean part of the world, because the lean part of the world in manufacturing strives for efficiency. We want to create things more efficiently, which you're kind of in this world where things are stable, things are certain, in that Stacy model. The requirements are known, things are stable, and so I want to improve efficiency. But that's going, and so now efficiency is no longer really that important. Adaptability is, because whatever I'm going to make, I know I'm going to have to change it. And in the book, I talk a lot about General Stanley McChrystal, actually, who wrote the book Team of Teams about this, and a wonderful story of how adaptability is now really the only thing you needed to survive. And companies like Microsoft and Apple, the only way for them to survive is to literally reinvent themselves every few years. And so adaptability requires a completely different mindset. It requires a different organizational structure, different systems. And so the challenge is, how do we move to thinking just about efficiency to how do we be really adaptable and respond quickly?
That's really great. That reminds me of a number of things. The first thing I should probably mention is, for anyone listening, before they make the sort of Mark Twain joke about the rumors of my demise have been greatly exaggerated, Stephen Wolfram is still alive. That concept you're talking about, actually, like, this is just arbitrary, because I like to listen to this podcast called Mindscape by a guy named theoretical physicist called Sean Carroll. He had Stephen Wolfram on like a year ago or something, talking about exactly the incredibly fascinating thing you and Jeff Sutherland were talking about. So anyone who's interested, Google Mindscape, Sean Carroll, and Stephen Wolfram, and you'll find it. It's really interesting. They kind of don't agree with each other, and so you get to see these sort of people talking at this high level about theoretical physics. But what you said is totally correct and interesting and like fascinating. And that's super interesting. But you also reminded me of something too, that this adaptability has become is actually something that's being discussed in sort of corporations, but it's also being discussed in militaries now as well. You brought up General McChrystal. The people in recruiting, in particularly the U.S. military, are concerned about recruiting for adaptable soldiers. Basically, that the mindset that you need is actually someone who's adaptable, who you can sort of say, you can give them a high level order, like take the hill, but you don't need to tell them any kind of in more detail than that. And how do you recruit for that kind of thing in the military is a very specific thing, but how do you recruit for that? I mean, it's interesting you bring up, like, how do you recruit for that for people who, like, their greatest asset is they have engineer brain, but it's also the thing that gets in the way maybe of accepting unpredictability and things like that.
Yeah, but so that gets into the direction organizations are heading in, and it is a very different way of working. So if you need a boss or a manager to tell you what to do, you're probably not going to fit into this new hyper adaptive model. If you are put into organizations, so to get really adaptable and fast, when you get into the in action, how do you do it? You need to be able to make decisions incredibly quickly. So essentially what it means is your organization needs to be flat, no management. So you go into an organization, and your job, you might be working in a particular area today, but tomorrow you're working in another area, because you have to adapt to what is needed. So organizational models now change completely. So completely flat, completely fast. And the only way to actually do that, to be able to not have management, is really through artificial intelligence and using AI as a digital self-management system. So now I will, well, let me give you an automotive example. So each Tesla car has a digital twin. So that digital twin, the factory and the digital twin talk to each other all the time. They build a relationship. They're talking to each other. So digital twin is in the field, even during manufacturing process. As the Tesla people will talk about, as the car gains consciousness, so that the car and the factory are in a constant dialogue. So if the car is in the field and then the car says, oh, the digital twin saying, oh, I'm experiencing heat in this particular area, the factory knows about it. So what will happen then is a team then will be formed on the fly to look at and fix that problem. So what it means is the AI is taking the entire management system and making the decisions. Hey guys, we need to work here today. So as an employee, I go in and then, oh, today I'm working on heat pumps. Tomorrow I'm working on paint improvement. How do I improve paint? So you need to become incredibly T-shaped. You need an expertise, but you need extreme, you be able to work in different environments. And if you're a manager, not actually really building anything, there's really not much you can do. So it's a completely different way organizations work, and people need to be adaptable, essentially.
That's so interesting. I have done work on sort of digital twin and stuff like that in the past. We used to do consulting at Leanpub for the sort of company that owns Leanpub, and I did some work on that. But so are you saying, and sorry to get so specific, but are you saying that every Tesla sold has a digital twin?
Oh, yes, of course.
Yeah, I was completely ignorant of that. That's fascinating.
So and it knows everything. The digital twin, and what's more is the digital twin is thinking. So the digital twin is constantly thinking to itself, how could I increase the distance traveled per charge? Is there something which maybe the way they're braking, the way they're driving? So it's using simple algorithms to run through. Is it technically possible to be able to improve this? And if it is, then it's then telling the factory, hey, here's an opportunity you guys should look at. So the digital twin now becomes to get really fast, or your manufacturing needs a digital layer now. And that digital layer is where you do a lot of the thinking and you do a lot of the scenarios. And this is in, companies like Tesla or in Saab Aerospace. How do you redesign a fighter jet on the fly and get, the FAA approval? Or how do I redesign a car and get roadworthiness certificate on the fly? Because what they're doing is they're using digital twins. So if I propose a change in the engineering model, then immediately regressions are done on that particular change to test, is it going to be roadworthy, yes or no? So every time people are doing work now, systems are doing regression testings on the hardware to figure out, is this safe? Is it roadworthy? So the feedback is instantaneous. That's how you get fast.
That's really fascinating. I had not thought of that. Now my mind is going in a million different directions, So for example, all of a sudden, if the Gripen fighter jet needs to be landing on shorter Ukrainian runways than it was designed for, because they, not up to NATO specs, then all of a sudden, you can actually, you don't have to start from the drawing board, but you're starting from sort of live data, and sort of regressing back to the point where the change might need to be made, and then going back forward again is just fascinating.
And what I'm trying to do is figure out for these large energy projects, how do we do the same? So agile and software, that adaptability, being able to extreme programming, release, code on the fly.
and lean. How do we? You need lean, of course. You need efficiency. You've got to be constantly, but then the adaptability and the speed. When you start to think about how do we create great products, amazing quality, really fast, things start to change in the way organizations are managed, the way leadership works, the systems. So what does that look like? So how do we do that? So that's where we're exploring now. In the hardware world, there's only a few organizations in the world that are doing this, but I think everyone else is going to have to survive, essentially. That's what I'm interested in. How do you actually do this stuff?
Yeah, and so this sort of allowing me to make a segue to the next part of the interview into bookseller joke. So you're saying everyone needs to read your book?
Look, let me tell you a story about the book, which is, the things we've been talking about. I've had a lot of trouble explaining to energy majors, and because their frame set and their mind. They've been very successful. They make a great deal of money, and the way they've been working is, they've done it well. And so when we introduce concepts like, instead of having silos, why don't you have Scrum teams, co-delivery teams, different organizations? Then they won't understand. They just can't frame what they're talking about. So over the last couple of years, I've been kind of taking notes, thinking about, okay, so when I'm explaining this, what do I do, and what sort of resonates, and that kind of how the book was formed, right? So, and what's more is, I've published a book before, and I can talk about that. The difference between publishing a book classically and publishing a book through Leanpub is one thing I realized is that this crazy fast agile hardware world, whatever I write, whatever I put forward is going to change pretty quickly. And so I need to be able to put the energy in to learn about what is happening out there, what is the best practices, put it into that book, and then release it like on monthly sprints, etc. So I wouldn't say I'm selling a book. I'm trying to create a movement of people who learn together. That makes sense.
That totally makes sense. I mean, I was sort of joking tongue in cheek, but that totally makes sense. And I know you write that. Let me find a line here. Given the rapid pace of innovation, the book will be updated regularly based on reader feedback and any new best practices, which basically makes it the perfect Leanpub book, and the reason we built Leanpub the way we did, right? To sort of like books. I mean, we'd love to have more serial novels and things like that, but like books that are about subjects that are changing, that the readers could definitely use updated sort of assessment or analysis from, but in the coherent package of a book is exactly what we were sort of built to have authors like you come and do, which is one of the reasons I was so excited to see your book appear on Leanpub.
And maybe let me talk a little bit about then. So my first book.
Yeah.
So this was many years ago, and it was about the same sort of subject. From a publisher, I'll talk a little bit about that experience. So I had an idea for a book. I was working in big tech company at the time. I had the idea, saying, hey, I should publish a book. So I started to write about it, and I got lucky enough to find a publisher. So John Wiley & Sons, a very prestigious publisher, said, "Hey, your idea is great. Let's publish the book," even though I hadn't finished the book. So then the process of publishing. Firstly, you're lucky to find a publishing house. This was back then, and they're very, very fussy. And then the actual process of writing the book was incredibly slow, and it took a lot of energy. And you always had the feeling that it was never complete. And you never wanted to publish because you always thought, oh, I could have done this differently, or maybe something new, or if I write this, maybe I'll get negative. I won't look maybe I'm saying something wrong. And so that publishing process was torturous. It was very, very challenging. I mean, the book came out, it was a bestseller. And then what happened is Wiley said, look, your book is targeting these big industries. We're going to charge $150 per book. I go, what? 150? So I didn't have a decision about the pricing. Wiley did. And it turns out that it would have been better if I'd priced lower, because the more copies of the book out there, the more I get to spread what I'm talking about. Whereas Wiley was trying to maximize profit. So they went, actually, let's be cheaper. I mean, more expensive. And then I got to the point of, well, so this sense of publishing is never really complete. And actually, even after I published the book, I couldn't stand to look at it. I to this day, I haven't even looked at it because I know I'll be disappointed with whatever I've written in it. But then Leanpub comes along and changes the game, right? So now it's better to publish and get feedback. Of course, I have to work hard, right? Of course, I've got to get the concepts right. But it creates a different dynamic, and it makes it less stressful, because I know what I'm going to produce could always be improved. And now I have a mechanism to do it. And to be honest, if I hadn't found Leanpub, I don't think I would have written another book, because I couldn't go through that old process, that old publishing process, which was the only one I knew. Right. So kudos to you.
Yeah. Well, no, kudos to you. I mean, thank you very much for explaining that. I mean, that, this particularly the kind of like emotional part of writing books is something that I think often gets kind of left out, because people want to talk about the subject that they're writing about, and they love talking about that. But actually, like, writing a book can be a very emotional thing. It can be a very difficult thing. I mean, who was it? There was an author in the States who was a, news broadcaster or something, who said, like, their spouse really hated when they went off to that room, because that meant that, like, for the next 3 months, 4 hours every night, the person's going to be away from their family and things like that. So a book project can be a really big thing, and taking some of the stress away, but without sacrificing quality, of course, right? And like the whole point is to build a process to sort of make your book better. But the fact that you can make it better means that you don't feel regret when you hit the publish button so much as you might, if it's a final thing.
Yeah, and the other thing, of course, is that so when I published the book, I was working in technology companies. I've just come from aerospace, and I knew how things would work in technology and aerospace. But that means that I actually have sort of a framing already set, just based on my experiences. So that framing is, I know how it works in aerospace. I know how it works in technology. But in other industries, because I really haven't been exposed to it, I don't know. And I can theorize that it would work that way, but the reality could be very different. And so the idea of being able to publish iterations and get feedback means then I can broaden that context, broaden the framing to actually get more and more input. So this idea of iterations and getting feedback, it really changes the publishing game. And I hope to get feedback and to build something that helps everyone, essentially. And I couldn't do that before.
Yeah, no, that's really great. That's really great. The last question I always like to ask on the podcast, if the guest is a Leanpub author or has used Leanpub, is and it's not a gotcha, but sometimes it comes across that way. But if there was one magical feature we could build for you, or if there was something when you're using Leanpub that just has you shaking your fist at the screen, why doesn't this work, or why is this broken? Can you think of anything you would ask us to do?
Yeah. So it took me a while to actually understand how Leanpub works. I know you've got a lot of things on the website, and I don't often have much time. So I think I found some YouTube videos which then, I get it. So I think you were talking about it. So that is helpful to actually get this model. But actually, for me, the tipping point was Jeff Sutherland, because I noticed Jeff put out a book And I thought, oh, wow, this is really, really cool. It's going to be a really good book. So then I bought it. And then a month later, I go, oh, here's an update based on the last sprint. I went, whoa. So it was really hard for me to understand this new publishing model. And even I was speaking at a conference yesterday on Agile, and I was talking to people from bank, etc. And they asked me about the book, and they kept asking me, why aren't you making physical copies? And I said, well, I mean, I could, but I don't want to, because I want to try and change it. They go, how do you change a book? But that doesn't make sense. And then I had to go through. So I guess from understanding that new publishing model, it took me time to figure it out, essentially. And now that I have, I'm convinced. And then the mechanics of the website, so that the more that I kind of would step into it, I would try something. So, oh, we created a landing page. Oh, okay, so what's that? Oh, put a photo here. So okay, then. So I just started. It took me time, and things like tuition videos, etc. It helps. I don't know if that answers your question.
No, that totally does. I mean, that's really great to hear. I mean, as you know, as you would know, when you're really close to something, sometimes you can be the furthest from it. And being reminded all the time that, like, actually new, up to date, just explanations about how this works and what this is something that we need to do. We know we need to be better about. It's so easy to let sort of like, oh, we did that, we've got a tutorial, but now it's 2 years old, kind of thing and stuff like that. And also remembering, I mean, the hardest thing for I mean, I guess, again, you're so close, you're actually far away from it. We understand, the lean publishing thing. We're totally comfortable with it. But like trying to step back and go, okay, what if you've never heard of this before, and sort of explain things. And like, so if someone's like, what is this? We actually don't have anything like that. Like, that's just like me in front of a screen going, so you're curious about what this Leanpub thing is? Let me just give you 5 minutes explanation. So I'm going to put that definitely in my queue of an explainer video to do, and just be a kind of like gentle introduction. Don't need to remember what I'm going to say or anything like that, but like, here's what we mean when we're talking about in-progress publishing. What does it mean to publish a new version of a book? Things like that are concepts that I can understand, can like take a little bit of time, particularly and like if I could have given you something you could have said to those people that was straightforward, and that you didn't have to work so hard to learn yourself or something like that, then that would have helped spread our idea better and stuff like that. So I'll definitely work on that. But Edward, thank you very much for this really fascinating conversation. I really enjoyed it. The book is really great. It's Agile Hardware in Action, a practical guide to building products for the fast-paced world. There's all sorts of interesting stories in it and things to learn, and I recommend it to everyone.
Thanks a lot, man.